Okay, I realize this, when I look at this function, I don't know how to graph that. Well, you have to start to realize that it's probably going to be pretty simple, and you don't have to get a terribly accurate picture of it. But, what am I looking at? I'm between 0 and pi over 2. And what does this function evaluate to at 0? 0. What does it evaluate at pi over 2? 0. So we got 0, and this is pi over 2. What do I know about the root? It's positive. So I'm going to maybe say something like this over here. By the way, it doesn't be terribly accurate, something like that. So what I'm going to do now, I'm going to just simply draw in my rectangle. What am I going to do now? Maybe continue to read it, make sure I understand what's read. Find the volume of the solid obtained by rotating the region under the graph of. When we got this, we know what the region is, by the way. The region is this business over here. And about the x-axis. So really what am I looking at? Well, that little rectangle being rotated. And I hope you realize if I do that, I'm going to get a disk out of that guy. Let me just put a little better disk for you. And that thing's going to look like that over there. So what I do, put the integration down. And the integration going to be, let's see, I like to do the differential first. The differential clearly is dx. This is dx over here. And what's the limit of integration? 0 to pi over 2. And let's take a careful look at it. It's going to be pi r squared. So pi, that's a surface area, by the way, r squared. Well, the r is actually what the y is, and the y is actually just the function f of x. And what's that going to be the root of? Let's write that down, sine x cosine x. Now, I realize someone's looking and saying, I don't think I could do that integration. We're not giving you things you can't do. That's not going to happen. So what I want to do is I want to go through it for you. I'm going to go over here, kind of running out of space, by the way. And what do you get? You get pi comes out. You get 0 to pi over 2. When you square that root, it removes it. What do you get? Sine x times cosine x, and then dx. All right? Now, someone says, how would you do that? I realize in the notes, I got something written down over here, and it may not be entirely clear what's written down over here. I want to go through that with you. But what I'm going to do is I'm going to start to erase some of the distractions now. Because really what I'm going to do, I'm at the level where I got an integration written down, and I think I can do the integration. All right? So let me point out, I'm at a milestone now. What's the milestone I'm at? I'm at this milestone over here. Now, granted, I'm looking at that, and I'm wondering, is there a way to integrate that doesn't require too many skills? And there is. You should be able to identify, and write this over here for that the sine of 2 theta is 2 sine theta cosine theta. All right? So I'm going to say, my integration now, let me look at it. This is pi, and I'm looking at this thing over here. And that's really going to be the same thing as the sine of twice x over 2. All right? Oh, by the way, limits of integration 0 to pi over 2. Sorry about that. Forgot to put that down. I'm going to pull a 2 out. And what do you get? Pi over 2. 0, pi over 2, sine 2x dx. Now, granted, there's many techniques of integration. I'm going to say, I'm looking at this thing, and I think I can do it by inspection. And I'll write this one down for you. So I'm going to say pi over 2, certainly, there's a constant multiple. What differentiates the sine minus cosine? So I'll write this over here. Unfortunately, if I were to differentiate that, I would get sine of 2x, but then I'd get a 2. So I need to take that away by dividing by it. And let's put this over here. This is going to be 0 to pi over 2. What do you do now? I guess I got to do some arithmetic now. Get pi over 4. I put the minus sign over there, and then evaluate cosine of 2 times pi over 2. So it'll be cosine of pi minus the cosine of 0. All right, let's take a look at that. What do you get? You get minus pi over 4. The cosine of pi is minus 1, and the cosine of 0 is just 1. So I get something pretty simple. I get minus pi over 4. I get minus 2 here, and that's going to give me pi over 2. Remarkable. Let's look at the answer key. Did we get this over here? Whoops, sorry about that. Did I get pi over 2 in the answer key as a final result? I did. And again, if you want to look at the work, you can. The work is written down for a reason. We would like you to read through it, by the way, particularly if you're struggling with this stuff. If you're not struggling with this stuff, looking at somebody else's work may be unproductive for you because it may confuse you. But for the most part, I am following the work as written, all right? My chicken scratch doesn't look as good as the typeset work though, and pay attention to that. Thank you.